Hello everyone, this is going to be Lock Design Video 5, bypass methods and how to prevent them. Before I get started in that, I want to show you a recent package I got from Otter Arms. He sent me some stickers. They look very cool, very nice logo there. I really like the grayscale and the color on the name there, very cool. And also a challenge lock he sent me. So this was made by Left Hand Loki and the engraving was by Otter Arms. It's called Balls Balls or Balls Balls. I'm not sure how to pronounce it, but it is a monster. I think I spent about an hour on it last Saturday or Sunday and didn't get it open, so it definitely kicked my butt. Hoping to get a little more time on it this weekend and hopefully get it open. But yeah, very cool stuff there. So the video, I'm going to go through the PowerPoint, Death by PowerPoint, talk about what is bypass, what are the methods of bypass, and how can we design to prevent it. And then after that, I'm going to take a look at these locks right here. We've got a few different locks we're going to bypass. We've got a safe door we're going to show some issues with. And yeah, that's going to be it. So if you want to skip the Death by PowerPoint, if you're not interested in that, feel free to fast forward and we'll start opening some things. Okay, but let's get into the video. Let me adjust this a little. All right, that should be okay. So the lock is only as strong as the weakest link. So we got a few examples here of locks that are not doing a great job. Well, if you can take a look at that, that's a panic bar on a door with a bunch of metal grating. There's a really good video. If you look this up, please protect your doors better. This is unacceptable. It is fun though. There's a short video from Nothing where he opens one of these super quick. Yeah, and then I'll let you figure out what's the issue with that guy. All right. So lock bypass. Bypass is a non-destructive. Sorry, y'all. Alrighty, there we go. Sorry. Bypass is a non-destructive method of opening the lock which does not require us to place the keying components, whether that's pins, discs, wafers, sliders, levers, wheels, tumblers, etc., at the correct positions. So we don't need to get them in the right position to open the lock. It is often much easier than manipulating the lock mechanism itself, so it's generally going to be easier than picking the lock. And it's generally going to take less time to develop the skills needed, which is going to appeal to criminals. So I think that the statistics I've looked at show that like lock picking is very rarely a way that criminals ever enter. I wonder like what percentage of that would be bypasses, because I think bypasses are going to appeal a lot more than actual single pin picking. And they can render what would be a very high security lock to something that's very low security. There's a really good example of this where the lock picking lawyer shows a video. It's called Unpickable Locks from Stuff Made Here, where he takes a very well-designed lock, a lock that's really been thought out, you know, very carefully about how to make it pick-resistant, extremely pick-resistant, from from Stuff Made Here. And the lock-picking lawyer, he bypasses it, and he does it really quick. And it's, you know, it's like, I'm sorry, I know he put a lot of effort into it, but you gotta, that's the issue with bypasses. You can have a very nice lock, but it's sort of like, you know, sneaking around the lock mechanism, and as the title, you know, as the name goes, bypassing it. So it really, you know, it's a shame sometimes. It can render some very nice locks ineffective. So what are some of the methods associated with bypass? So bypass covers a ton of different things. There isn't like one bypass method. There's a lot of stuff that can fall into it. Probably the most common is going to be shimming. That's going to be your credit carding, or you're cutting open milk bottles or soda cans and you're using that metal to open doors, like credit carding doors or shimming padlocks. Another big one is going to be manipulating the actuator. That's going to be your hooks, your bypass drivers, your bypass knives, your Slim Jims, your coat hangers, and the car window. Those are all going to be avoiding the lock and going after the actuator. You have overlifting, where you're using comb picks, where you're lifting both the key pins and the driver pins above the shear line. That tends to affect very cheap padlocks. You have trigger request to exit sensors, where people use dust off or some kind of refrigerant to trigger the passive infrared motion sensors that are used for like exit doors. That's going to be a big deal for a lot of commercial businesses, a lot of the larger businesses. There's trigger reset switches that you see on a lot of safes. I'll show an example of that here. Those can often be triggered in a way they weren't intended to just change the pen really quickly. You can manipulate the internal door handle. That's going to be your letterbox tool. It's quite literally named for going through the letterbox and trying to actuate the, move the door handle in some way. Going under the door tools, thumb turn J tools for sort of going through commercial doorways and just flipping that switch. And then coat hangers, also like you would oftentimes see on car doors. Yeah, reaching in there with a coat hanger, trying to pull the door handle. You can have kinetic attacks, and some people might not consider bump keys or snap guns bypass methods. In my mind, they are. They're similar to overlifting. It's not actually the pins aren't actually at the correct position, and the lock opens. So I put bump keys and snap guns in there, but there's also other kinds of kinetic attacks that are aimed at the bolt itself, the spring-loaded bolts. And I'm not sure quite the proper name for those, but I'll call them kinetic attacks. You have disassembly issues where you can take a hammer and a screwdriver, or one of those hammerless hinge pins. I mean, just quite literally knock the hinges out of the door, take the lock apart kind of situation, if it's easy enough. And then you also have magnetically opening solenoid coil actuators that can be with a really strong neodymium or electromagnets. There's also something called a mag switch. I know it's sold by Red Team Tools. And that's kind of a neat device. It's sort of, you can deactivate the magnet, but it's not electromagnetic. So it's kind of interesting. But yeah, there's a lot of methods out there for a lot of different locks. There's also some magnetic methods for, I'm not sure, it's not solenoid coil actuators, but it's something else being used in some of the simplex locks. And this probably isn't covering everything else. There's probably stuff I'm missing. But that's some of the big ones right there. All right. So how do we prevent bypass methods? So number one, prevent movement of the actuator or bolt unless the keying components, those pins, discs, wafers, sliders, levers, wheels, tumblers, etc., are at the correct position. So the bolt should not move unless the key is inserted and turned or pushed or however it needs to be moved, such that those components are at the correct position. If the key is not in there and putting those correct values in, that bolt should not be able to move in any way. That is the easiest way, I think, to prevent bypass methods. The biggest method right there. So that means the bolt should only be able to move if the locking mechanism and the keying components are in the same position they will be in when the correct key is inserted. And that's something you've just got to sort of think about with the design. And I think it's best to go backwards from the bolt towards the lock actuator and towards the lock and see, is there any way I can finagle this so that it would open without the key being in. And this means the lock should not be able to close into the locked position without the key inserted. And if it can, this is a very strong red flag that there might be a bypass method. I know there are locks that you can close that are not, I don't want to say you can't bypass them, although I'm tempted to. I'll say I don't know how you would bypass them, because they are made well enough that I haven't seen anyone do it, some of the ball bearing ones that you can close. But I would need to look closer at that to see exactly. I know that you can't shim those in a traditional sense. But I think there's some more stuff going on in the actuator that prevents that. It's not just the fact that they're ball bearings. Yeah, so I would just say that it's a major red flag. It doesn't have to be, you can't do it, but it is a very big red flag. Do not use ratcheting mechanisms or spring-loaded bolts. I'm just going to say that's just as a rule that those are bypassed so easily and they so often fail that I would just say do not use them. There are better options. Use linear actuators with lead screws instead of solenoid coils. So it doesn't necessarily need to be like literally a lead screw, but some sort of motor that is rotating and not a solenoid coil, that it can move something linearly if you need it to extend or retract a bolt. So something like this, and not something like that, as you'll see in a little bit. Okay, because essentially the solenoid coil actuators are another form of spring-loaded bolt. So that's really for electronic locks, but just stay away from them. All right, so how to prevent bypass methods 2. Prevent access to critical components. So ways we can do that: require a key to disassemble the lock. If you don't need a key to disassemble the lock, there may be some weaknesses there. Require the key or pin be entered or the bolt to be retracted to change the keying or pin. So it's not enough to assume that just because you can access some switch that you actually have the authority to press it. But if you make that pin or that reset mechanism work when the key is inserted or the bolt's been retracted, then you have another layer of security there that should hopefully enforce some sort of authentication via the key. Create walls where tooling needs 90-degree bends to move past. So if these are done in series, it is very unlikely a tool will slide past them. And you can see this on pretty much every pen tumbler, a really good example of that. So on the very face of every pen tumbler where the plug goes into the housing or that shell, there's generally a protective lip on the outside of that plug that creates two 90-degree angles. And that is why we cannot shim those pins from the face or the front or the face of the lock. It's very simple. But just by adding a couple of 90 degrees turns in there, it's very unlikely we're going to get a tool in there. And even like some of the shimming you see on the Kwik-Sets is in big part due to like little cutouts they have on the plug. If they had done something like this, I think it would be a lot harder. I'm kind of surprised they don't have something like that. I guess it has something to do with manufacturing. Yeah, but those angles will be very helpful. And also with the walls, you can see here in this image right here, using the security disc on the back of this American plug to prevent a bypass driver from going through and interacting with the actuators. There are tools to bust these out, and some people you could argue it's a bypass method in the sense that most people won't see the destruction, but it's a little destructive in that it damages that wall there, that disc. Okay. So use internal hinges instead of external hinges. Yeah, I think that one's mostly common sense there. Fill pre-drilled mounting holes with bolts to prevent access. Allow user to remove and mount. So maybe that's going a little far, but I've seen that on a lot of safes that you get a lot of access through other mounting holes. And on a well-made safe, that's not going to give you any advantages. But on a lot of cheap safes, like this one I've got right here, those can be make it very easy to access components, whether you want to try to unscrew stuff or you want to try to hit the reset switch. There tends to be a lot of access there. And then glue is not a secure fastener, so do not use it, as I will show you momentarily. Okay. And then the last thing I would say, I mean, this isn't a rule, but I just think something good, and I mean, this doesn't just apply to this, but it applies here, which is get some outside opinions. Bypass methods tend to think outside of the box and use the lock in ways it was not intended. It's easy to get tunnel vision. You're just concentrating on your design, and you're not considering other approaches people might take looking at the lock. You're assuming they won't go about it that way, whereas an attacker might not. So I think it's good to get a second set of eyes to take a look. Yeah. So that's the general rules, I think, for bypass. I think it's hard to say specific rules. I tried my best there, but it's one of those things that there's so many different bypass methods that have so many different approaches. You know, it's kind of hard to say this is exactly how you do it, because you also want to have a lot of different lock designs. So I'm going to show you some bad examples here. I'm going to show you one that I think is actually a decent example. In some respects. But yeah, let's just go through here from, this is probably the absolute worst of them all. So this is why we say don't use spring-loaded bolts. Oh, it's going to be weird now. There we go. I don't know if you saw that. We just tapped that open. Because it's got a super weak spring in there, we can actually just sort of knock the bolt around, tapping it. And even though this is an electronic fingerprint lock, we can just tap it open really quick. So don't use spring-loaded bolts. Let's see, this guy is another example of don't use a ratcheting system. So look here, we just pull that up like that, and we can move it out. Sorry, keep going with it. So we can take this off. What's crazy is this is actually sold. If you look on Amazon, they call these things high security. That's absolutely, absolutely nuts. But yeah, we can, the ratcheting system, and there are other forms of ratcheting system, but the idea is the same. You're shimming it like that. And we can do that really quickly. So that's why I just stay away from it, in my opinion. The same principle applies with handcuffs. Handcuffs are a little different because you can double lock them. So it's not completely fair to say, you know, they do have two methods, but at the same time, you can see ratchet systems by themselves are not effective. So we can get past them real quick. You heard me talk about glue. So this is a cool magnetic lock, right? Should be very high security, should keep us out. We shouldn't be able to get it open. That's it. This is, in mine, I don't even think there was glue. I'll be honest with you. I said glue, giving them the benefit of the doubt that maybe at some point there was. But there is absolutely nothing holding in, as far as I can tell, this cover plate from keeping me from opening this lock. So you can literally just hit it with a hammer or something and just knock this plate off. And then you can do whatever you want to this lock to open it up without anybody knowing. Yeah, and yeah, that's just crazy. That's crazy, you know? So make sure your lock is not easily taken apart. So this is an interesting one. This is one I'm sure a lot of y'all have seen. This is the Master number 179. And this one we can bypass. We can take, I'm using a 19 thousandths. Doesn't matter which hook you take, but like a 19 thousandths hook. I can come in along the side with the numbers upside down here. I come down in like this. I go in, twist, push back, and go like that. So go down, turn, push back. Then I press in the shackle, press down, and we can pop open the lock right there. This is also another example of, you can see here we have the wrong combination in. I don't know what the right combination is, but you can see here, this is like a spring-loaded bolt you would see on a house door. And we can push that down even though we don't have the right combination in there. So that's a huge indicator that the lock may be able to be bypassed in some method right there. Because we know for a fact that these don't have to be at the correct position for this to go down and therefore this to come up. So there may be very difficult to get that to go down, but it may be easier than getting the right combination there. So that's the big warning. And I just figured I'd show one actuator bypass because it's, yeah, so common. So in here, there's a couple of locking bars to the left and right. And we're just trying to move the locking bars up and such that we can, that the shackle will pop up. Yeah. And you can see that's pretty quick and easy. So those are all pretty quick opens. I did want to show you this quick. So technically this is a pen tumbler, and you could bypass this by bumping it. So it's not a great example. But what I do want to show that I do like about this is the bolt here is directly connected to this key. I've actually never cut one of these open, so I hope I'm not sticking my foot in my mouth. But you can see I can't rotate this without moving the bolt. And if I move the bolt, I also move the plug there. So they very much appear to be directly linked. And that is what you want in a locking system. You want this directly linked to your plug so that is going to prevent bypass methods right there. In this case, the plug itself is the weak spot, the locking mechanism itself. But that's good. That's in the sense of at least this housing isn't the weak spot. Okay. And then the last thing I wanted to take a look at was this safe door. I actually took the safe door off for y'all. So I hope y'all like that. The first thing I want to show you, so this is, if you're looking at it from the back side, you can see that there is a little button right here. This is a reset button to change the combination. And like many cheap safes, you can press this button whether you have the right combination or not to change the pin. And I'm sure they do that because it helps with, I don't know, customers changing their pin for the very first time. The problem is there's so many mounting holes on these cheap safes that you can almost always reach back in there with a coat hanger or even like a wooden dowel and press this button, and then you can enter your own pin and reset the combination. So that's a big problem with it. You can see here that it goes down to the board right here for these two, for the reset there. I haven't fully taken this apart, but what I can see is that there is a little gap for the cable there that goes up to it. If you wanted to get destructive, you could knock off the front panel and probably just short those real quick too. That might be something that, you know, a less skilled attacker would go after. This one, let me see if I can show you the front real quick. So this is like what the front looks like. You can see the way that I got into this. This was, I was opening this for family after somebody passed away. My cousin, he was a really good guy. But this was his. You can see here underneath the batteries that it used a pin tumbler lock, which is what I used to open it because it was easier than trying to guess the combination. But yeah, we use the pin tumbler lock. That's often a weak spot of these things, is they don't have the best backup locks for security. You can usually replace these though. These are just cam locks. So if you wanted, you could replace that with a Medeco or something like that. I know somebody who does that. They'll replace their cheap safes with a nicer locking mechanism. And then I guess the last thing I'll show here is, this is what I was talking about the solenoid coils. So if you see something like this where you can just push down on it, that is a huge warning sign. What you really want is something like this where it screws or rotates like that. And let me show you why this is so terrible. So I don't have a strong enough magnet to do it from the outside, but you could buy one. It's definitely possible. So here's a very strong magnet. I'm going to do it from this side. I think you can see there. That clears it. And then we can open up the safe there. And so that's the problem with these. These solenoid coils work by having an iron bolt. And with an iron bolt, with a big enough magnetic field, we can pull it down. And so there are videos of opening various safes by just putting a magnet on the outside, and they're able to pull that actuator down. In fact, I recently saw it, and this isn't just cheap safes. I recently saw it on a very nice safe. I'm not even going to say what it's for, because it is used for things that I think people would be, they'd be willing to be very dangerous or take a lot of risks to get into. So I'm not going to say what it's for. But this is a common mistake that it just should not be done. Just don't use these. Even if you don't have a magnetic attack, I've seen videos where people were able to get the timing right, hitting them with hammers and dropping them even, where they get the timing just right, where they can get that force to go down and it pushes it down, and then they turn the handle at just the right time and the lock pops open. You should not be able to open a safe that way. That's absolutely terrible. But I think that's all I've got on it. And it's coming up on 25 minutes, so that's long enough. All right, y'all. I hope that was enjoyable. Hope you learned something. Hope it wasn't too boring on the PowerPoint slides there. If you have any questions, comments, concerns, please let me know down in the comments below. If there's anything you'd like to see more of as far as like the lock design videos or any other videos, do let me know, and I will get to them, or I'll try to get to them. Yeah, thank you all for watching, and have a good weekend. Bye.